In this video, I will walk you through free response question number 1 from the 2007 AP Calculus exam Form B. This problem deals with area and volume. It is calculator active, so we will use our graphing calculator as needed. Let R be the region bounded by the graph of y equals e to the 2x minus x squared and the horizontal line y equals 2. Let S be the region bounded by the graph of y equals e to the 2x minus x squared and the horizontal lines y equals 1 and y equals 2 as shown above. Part A. Find the area of region R. You can find the area between two curves by integrating with respect to x if you integrate the top function minus the bottom function. In this case, the top function is e to the 2x minus x squared, and the bottom function is 2. In order to complete the integral, we need the limits of integration. So we need to know where the region begins and where it ends. Let's use the graphing calculator to find the intersection points between the red function and the green function. So let's type e to the 2x minus x squared into y1, and let's type 2 as y2. Hit y equals and type in the two equations. Before we graph, let's adjust the window. Looking back at the picture that they gave us, let's think about an appropriate minimum x and a maximum x and a minimum y and a maximum y. So to include this picture, let's do a minimum x of -2 and a maximum of 4. So I'm going to go -2 and a maximum of 4. I just want my calculator to look as much like this as possible. And for the y values, let's go from -1 to 3. Alright, so x min, let's do -1, and x max, let's do 3. So hit graph and take a look. We want to find the intersection points between the red graph and the green line. Hit second trace to access the calculate menu. We want option 5 for intersect. Move the pointer close to one of the points of intersection and just hit enter. Then it says second curve, just hit enter again. And then it says guess, just hit enter again. So the x-coordinate is 0.446, etc. I want to store this value into letter A on the calculator. So I'm going to quit out of here, second quit, but I will immediately type the X button and the store button, and I want to store the value, the X value, into letter A. So alpha A and enter. So all of these gorgeous decimals have now been stored into letter A. So let's write this down, 0.446. Okay, so I'm going to write A equals 0.446. All right, and since I'm using capital A, let me go ahead and write, let me go ahead and write capital A right here as well. And now let's go ahead and find B. And I'll put a capital B right here as well. So hit second trace again, intersect. Move the pointer close to the second point of intersection and hit enter. Alright, just hit enter again and hit enter a third time. Let's store this into capital B. So second quit, X, store, alpha, B. Let's write this down, 1.554. Doesn't matter if you round up or if you just truncate and put 1.553. I always round because that's what I'm used to. So I'm going to put 1.554. I am now ready to evaluate this integral. When I do this, I am not going to type in 0.446. I'm going to use the letter A. Similarly, I will use the letter B when I do my integral. Also, just so I don't need to type these functions in again, just remember that we typed the red function in as y1, and we typed the green function in as y2. So when I type this in my calculator in a moment, here's how it will look. I'm going to type in the integral from a to b of y1 minus, well, okay, this is just so simple. I'm not going to bother doing y2. I'm just going to go ahead and do the 2. All right, so this is actually what I'm going to type into my calculator. So here we go. For the integral, hit the math button and then choose option 9. And we are integrating from a to b. So I'm just going to hit alpha a and alpha b. And now I want to do y1 minus 2. For y1, hit vars and go to yvars and choose function and choose y1. You're welcome just to type in the whole function. If you would rather type in e to the 2x minus x squared instead of doing what I just did, that's fine. You can just type it in if you want to. So minus 2. And then dx, and that's it. So this is the area, 0.514. On the AP exam, you should always write your answer as a sentence. So the area of R is 0.514. By the way, you have to write down A equals 0.446 and B equals 1.554 if you want to use this notation and then refer back to it as A and B. Don't just put A and B without saying what they were. Alternatively, you could write 0.446 instead of writing A. Let me point in the right spot. And you can write 1.554 instead of writing B if you just want to fill it in. Part B, find the area of S. When we integrate with respect to x, we know we can find the area between two curves by integrating the top function minus the bottom function. However, we have to be careful with region S because the top function changes. Between 0 and a, the top function is the exponential function, shown here in red. Between a and b, the top function is this green function, which is y equals 2. And then between b and 2, the top function is back to the exponential function again. So we need to write 3 separate integrals and add them up. So for the first integral, the limits of integration are from 0 to a. And we're doing top function minus bottom function. So the exponential function, e to the 2x minus x squared, is the top function, and then minus the bottom function, which is y equals 1. And now the middle function, I'm integrating from a to b. And now the top function minus the bottom function. The top function is 2, and then the bottom function is 1. So it would be silly to leave it like this. 2 minus 1 is just 1, so let's go ahead and simplify that. All right, and now the third integral is from b to 2. top function minus bottom function, we're back to e to the 2x minus x squared. Whoops. That's the top function minus the bottom function of 1 again. So we just need to type all of this into the calculator. For integration, hit Math 9. And for this first one, we are integrating from 0 to a. And remember that we typed the exponential function into y1. So I'm just going to do y1 minus 1. It's quicker. So I hit vars, yvars, enter, and y1. So that's the first one. Now here comes the second one. Hit Math 9, and we are integrating from a to b. Okay, so a to b. And this was just a 1. All right, so that's the middle one. Now here comes the third one, Math 9. And this one is from b to 2. And this will be y1 minus 1 again. So vars, yvars, enter, y1 minus 1. And there you go. Not much to this sentence, but I would still write one. The area of S is 1.546. Part C. Write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 1. When you rotate region r around the line y equals 1, it forms a solid that's in the shape of a ring. Imagine putting your finger right through here. All right, this might be a solid gold ring. A single slice of this solid is a washer. That's a disc with a hole in it. We can use washers like this one to calculate the volume of the solid. It's a 3-step process. Step 1 is to find an expression for both radii of the washer. So we need to find an expression for the outer radius, which I will call big R, and also the inner radius, which I will call small r. Let's start with the big radius. When the radius is vertical, we can write an expression by subtracting the top function minus the bottom function. In this case, the top function is e to the 2x minus x squared, and the bottom function is 1. Now let's find an expression for the small radius, again by subtracting the top function minus the bottom function. In this case, the top function is 2, and the bottom function is 1. But 2 minus 1 is just 1. So that's it for step 1. We have an expression for the big radius and the small radius. Step 2 is to write an expression for the area of the washer. You can visualize the area of a washer as the area of a big disk minus the area of a small disk. In other words, the area of a washer will be pi big R squared minus pi small r squared. Since we already have an expression for big R and small r, we can write an expression for area by writing pi big R squared minus pi small r squared. So this is an expression for the area of this washer. We don't really need the 1 squared since 1 squared is just 1, so you could erase that if you wanted to. The last step is to write an expression for volume by integrating the area. Since we already have an expression for area, all we have to do now is integrate this. When you integrate the area of a washer, you are adding up all of the washers to form the volume. Since the washers are stacked up from left to right, we will integrate with respect to x. And since the washers are stacked up between A and B, we will integrate from A to B. Let's write our answer as a sentence. The volume of the solid of revolution is given by the integral from A to B of pi times e to the 2x minus x squared minus 1 squared minus pi dx, where A is equal to 0.446 and B is equal to 1.554.